Welcome back. This is part 5, in which we discuss the methods of determining the reliability of an instrument in quantitative research. To test the reliability of our instrument, we can use either the external consistency procedures or internal consistency procedure. Now let's look at two methods of testing external consistency: test/retest, and parallel forms of the same test. Test/retest is a commonly used method for establishing the reliability of a research tool. This method involves administering an instrument once, test, and after a while, we administer the test again, retest, under the same or similar conditions. An easy-to-understand example is a proficiency test. For example, we have just developed a proficiency test. We want to know if the test is reliable, and we administer it to a group of Year 1 students. A few weeks or months later, we administer the test again. This step is called retest. Afterward, we compare the scores of the first test administration and those of the second. If the scores of the test and retest are similar, we can assume that the test is reliable. So now this is clearly the advantage of this test/retest procedure. We can compare the test with itself. Thus, we don't have to construct two similar tests. However, there is one disadvantage. The disadvantage is that during the second administration of the test, the students may remember the test items. They may be able to score higher than in the first test. As a result, this can affect the reliability of the instrument. The second procedure involves using two tests. We have two tests that are very similar or the same. We can either administer the two tests to the same population or administer each test to two similar populations. There are two advantages. The first is that the students cannot recall the test items, so recall is no longer a problem. Secondly, we don't have to wait for some time before administering the same test again, as in the test/retest procedure. However, there are two disadvantages. First, it can be harder to develop two similar instruments. Second, it can be difficult to ascertain that the two instruments, or tests, are comparable in every respect. So now, in summary, in the test/retest procedure, we use only one test twice. In the parallel forms procedure, we use two similar tests among one population, or use each test with one of the two similar populations. Now let's look at the last method of ascertaining the reliability of our research instrument. Here we focus on achieving internal consistency. To achieve this, we need to use a method called split-half technique. The split-half technique is designed to correlate half of the items with the other half, and is appropriate for instruments that are designed to measure attitudes towards an issue or phenomenon. Here, supposed, there are 30 items in our questionnaire. We can divide the items into two halves, or two groups of items. Each half consists of 15 items. Ideally, we group the odd-numbered items into one half, and the even-numbered items in the other. This is what is called split in half. And then we compare the average rating of the first half with that of the second half. Kumar suggests using the Sherman-Brown formula to correlate the two halves. Other sources recommend the Pearson's correlation coefficient. All these statistical tests are available on SPSS. If the two means correlate, the instrument is said to be reliable, with all the items consistently measuring the same concept. Now that's it for the 3 procedures that can be used to ensure the reliability of a quantitative research instrument. What about the concepts of validity and reliability in qualitative research? Our attention will turn to these concepts in Part 6.